Hello everyone. So today we'll start with SolidWorks basics. In basics we will see line command, how to apply relations to line command, and how to see whether the sketch is completely defined or not. So to start with, I will click here File, New, and say Part. As soon as we enter in SolidWorks, this is the introduction part. So first at lower right side you can see the unit setup. From lower side we will see first one is IPS inch pound second, second is millimeter gram second, third is CGS centimeter gram second, and fourth is MKS meter kilogram seconds. So the selection of unit depend on the type of object or size of object. So now at lower left side you can see UCS, user coordinate system. It is used to define the direction of the working plane. At left side this area is nothing but model tree, in which whatever sketch you do, whatever feature you apply, everything is saved and you can access and change or modify the features or sketches here. So this is called as model tree area. The terms are very important here. Which one is model tree, which are the tabs, where is the unit selection and all. Now to start with the sketch, first we will say activating the plane. Now there are three types of plane given here: front plane, top plane, and right plane. And center of all plane is origin. So we'll start with front plane. To activate the plane, click on this symbol here. You can see one icon appearing here, C type icon with star mark. You just have to click on this icon and your plane is activated and your origin is also highlighted. So whatever drawing we are going to draw here, any sketch, we will start with from origin only. We have to give references from origin. So we'll start with line command first. There are total three types of lines. First is regular line, second is construction reference or center line, third one is midpoint line. So we'll start with regular line command. Now we'll start with origin as discussed. You can see a vertical line here. How we can decide that line is vertical? One relation is being appeared here in yellow color showing that line is vertical. If I drag the line in inclined position, that relation is gone. Again, when you make the line vertical, the relation is there, showing that line is vertical. Same with horizontal. Now the relation is not there, but whenever I make this line horizontal, at exact 180 or 0 degrees, it will show the yellow color icon showing it as horizontal line. Drawn one line here, but the endpoint of line, you can see the color is blue. It is showing that line is not constrained or fully defined. That's why the line is moving. Now our motive will be here to completely define these sketches. Whatever the sketch it may be line, rectangle, circle. You just need to completely constrain or fully define these sketches. So for fully defining these sketches, I'll put up some relations and dimensions here. First we will see dimensions, how to define the sketches with dimensions. So for giving dimension, one command is given here, that is smart dimension. Select the smart dimension command. This dimension command is used for giving radius, diameter, linear lengths, angles, and all type of annotations. Only one single command is given here. So I'll select the line command and put up the value. I'll say it as 200 mm. Now you can see the line is constrained or fully defined. It is shown here that line is fully defined. Suppose if I drag this line now, it will not move. It is fixed now. Suppose if I draw this line other than origin at any place, then the rule will be first to give the length of the object, whatever object it may be, then to give ordinates from origin so as to refer the line or position of line from the origin. So I'll give the line length first, then I'll put up the ordinates values as x and y values from origin references so as to constrain the position from x and y distances. As the plane is two-dimensional, the sketch will move in x and y direction. You can see the line is moving x direction, but now it will not move in y direction because I have given the value here, vertical distance. Now to constrain the horizontal distance, again I will do same the thing, that I will smart dimension it again by giving horizontal value, that is x value. Now the sketch is completely constrained. So by seeing, you can observe here that when I have drawn the line from origin, I only needed one dimension to constrain. But other than origin, I needed three dimensions to constrain the same line. First one was its own dimension, second was x dimension, and third was y dimension, so as to constrain the movement from x and y directions. Now the line is completely defined, or we can say the line is fully defined. In this way, you can define the sketches, whether it may be circle, rectangle, same thing we are going to repeat, that is giving the object dimensions first and then referring the x and y dimensions from origin so as to constrain the movements in two dimensions. Now, if I draw the same line in inclined way, I'll put up the first length, that is its own length. Now you can see two lengths are being appeared here. First one is linear, second one is align length. So align length only will give the actual value of the line. So I'll put up the align length here. I'll say it as 350 mm. Now to constrain it from origin, I'll put up the x and y values as we have done previously here. So I'll put up the x and y values from origin. You can select any one point to define. First I will give horizontal value here. Second I will give vertical value. But still the line is not defined. So if anything is not defined in sketch, you just need to pick one point, underdefined point, and drag it. Now this movement will show that line is rotating. Means an angle is needed to define the sketch now, to log this rotational movement. But for giving angle, I need one reference line also here. So I'll draw center line, second type of line, center line, from the fully defined point. You can see this point was defined as we have given dimensions x and y to this point. So I'll draw a line from this point only, as it is the fixed point now. So I'll draw one line, center line from fixed point, and now I will put up the angle value here. You can see I'm putting the angle as 45 degrees. Now the line is completely defined. Your sketch is showing as fully defined. You have to notice one thing, that we have not given length to this line. When construction line is drawn, only the position of line is needed. There is no need to give length to this line to define the sketch. Even if this length is not given, the sketch is shown as fully defined. Now, suppose I want to give relations to line and define the sketch. I will start with relations now. So for giving relations, I'll again draw one line here. I will intentionally draw it inclined. But now if I want to make it vertical, I will select the line and one chart will pop up here, showing some relations here. So if I want to make this line vertical, I'll say it make vertical. Now whenever you will click the line, you will show this relation, that is vertical relation, and it defines that line is make vertical now. Now if I want to merge these 2 points or coincide these 2 points, I can give relation in between 2 points also. So the relations depends on selection of types, such as if you select line and line, the kind of relation will appear only for lines only. But if I select point to point, then the relations that are possible between 2 points will appear on left side. So I'll select first point and origin point. Now you can see at left side the possible relations are being appeared here. So we can see here that if I want to make coincide, I'll say the points as coincide. Here you can see the relation, third number. Now you can see that points are merged, or we can say that points are coincide. I'll undo the relation. The second relation I'll see here is vertical. I'll say the relation vertical. Now you can see that points are in alignment as vertical. Means there is a vertical alignment between 2 points by giving the vertical relation. I will again undo the command and again apply the other relation. The last relation is horizontal. If I say the line is horizontal, then these 2 points will appear horizontal in orientation. So these were the relations. So I can see by clicking on the line that there are total two relations here. First one is vertical for the line and second one is between points, showing that these 2 points are in horizontal orientation. When the relation is applied as horizontal, if I drag the line at downside, it will not come at downside. This relation will restrict the y degree motion here, that is downward motion here. And even I can drag it here because the length is here not given. So I'll define the length also here. I'll say it as 600 mm. Now to fully constrain the line, I will see the relation, I will see the movement again here. I'll drag the line. Now you can see the line is being dragged in horizontal direction. So we'll put up the horizontal dimension here and put up any value here. I'll put 300 mm here. Now you can see the line is fully constrained again, fully defined line. Now we'll see some more relations here. I'll draw 2-3 lines here. First this line, in second this line, and third, and then the last line. I'll say it horizontal relation, and now I'll put up the relation between point and line. So the selections will be point and line. For multiple selection, it is compulsory to hold the control key and then select the entities. So it will take multiple selections, or else it will take only one selection at a time if you don't hold the control key and then select. So it is compulsory to hold the control key and then select the multiple entities. Now the relations appearing here which are possible between point and line are midpoint, coincide and fix. We'll ignore this fixed relation here and see midpoint relation first. As soon as I click the midpoint, the line gets grasped at the midpoint of this line. I'll undo the relation, and now again I'll see the relations between that point and line and say as coincide. Now you can see this line is grasped on this line but at random point, not at midpoint. So coincide will just connect the line with point, and midpoint will connect the line with point only but at midsection, at midpoint of the line. So this was the difference between midpoint and coincide relation. That was possible only between point and line. It is very important that what we are selecting, whether it is point or line to line sketch relation, that is important. Now we'll see some more relations. Suppose I want to make this line parallel to this line. I will select both the lines. I'll select the whole button and say this two line selection. Now you can see whatever the possible relations are appearing on again on left side. I'll say it parallel. Now both the lines are parallel to each other. I'll again draw one more line here. And now I'll say perpendicular relation by holding this line and control press again, holding this line, selecting this line. Now you can see perpendicular relation is being appeared here. I'll say it as perpendicular. You can see both the lines are perpendicular to each other now. Now if I want to merge these 2 points, we have seen coincide relation first. Now again see similar kind of relation one here, that is merge relation. So I'll select control point and again second point. Now you can see the relation here. First we have seen coincide, now we'll say it as merge. Merge will also act same as coincide relation. It will merge both the points and combine the object. Now if I draw 2 lines here, first one is vertical line on left side and other on right side of this constraint line, and I'll say this constraint line relation as construction. So you can make solid line as construction line by clicking this option here, and again you can make the line solid by clicking same option again. So I'll make this line center line here, as we are going to see symmetric relation. Now what symmetricity means is, if I place these 2 lines on both sides of center line, so I'll give the relation by selecting all the 3 lines. I'll select all the 3 lines, left side line, center line is must, and then right side line. And now I'll say the relation as symmetric. Now both the lines are symmetric to center line. It means if I drag left side or right side line, both the lines will be dragged at equal distance from center line. It is shown that the lines are symmetric. This symbol is showing here the symmetric relation. Now suppose I give the value here. I'll give the value here as 200 mm. You can see other line also get placed at 200. And if I change the value, suppose I'll say 350 mm, the other line also will move at 350 mm distance only, same distance only. So this is the symmetric relation. Now, if I want to make all the base orientations same at horizontal position, I'll select all the 3 line endpoints and say all the lines as horizontal. You can see all the orientation of base is at horizontal position now. Now I'll select this line and delete. You can select and directly say delete button so as to delete the lines. Here you can say undo. Again that lines will appear. Again I'll select and delete it. Still the sketch is showing underdefined. So I'll define the sketches by giving the value here. I'll say it as 600 mm. But still this line is not defined. So I may need to give dimension to this line also. But one smart thing I can do here is by adding relation. Suppose I make one relation that's saying that this line is equal to this line, then I don't need to put up the smart dimension here also. So I'll say selections of both lines and the relation I'll say is equal relation. As soon as I say equal, now this length 600 is implemented on this line also. Suppose if I drag this line, it will not move as it is of same length with the right hand side length. So I'll change the value again here and say 800 mm. You can see the length of this line also changes similar to this line. Again I'll say 200 mm. The change is appeared here also and it is also 200 mm now because of this equal relation being applied here. So it is smart way to work with relations, as you don't need to change every time the dimension. You just have to need one time change and all the dimensions will apply with the same length if the relation is given as equal. So relations are very helpful here, and most of the design engineers suggest that if you work with sketch, you have to work with relations. So it is easy to define or edit these sketches. Some more things here. Suppose if I press the cursor and drag it, the plane will get tilted. Now again, to normalize the plane or to bring back the position of plane, I'll select this sketch and say normal to command. Here you have to remember the name. The command name is normal to. Symbol is an arrow at vertical side. You can apply this symbol from here also. In view orientation, this option is given here as normal to. Again, the plane is normal here. So if you are having problem with tilted plane, you have to normalize the plane, then select normal to, and you will have the orientation same as earlier. Now if you want to exit this sketch, if you are overworking with this sketch, you can exit the sketch here. This icon is showing the exit sketch symbol. I'll click on this blue icon, and now we are out of this sketch. You can see in model tree, sketch 1 is here being highlighted. If I click on the sketch, it will be highlighted in sky blue color here. So if I want to again activate this sketch or edit this sketch, I will select this sketch from model tree, or else I will click here and say again edit sketch. Now this sketch is again activated. Now we will see the last line type, that is midpoint line. As the name suggests, it will start from midpoint of the line and symmetric on both sides. I have drawn this line from origin, so I just need to give one dimension only here so as to define the line. So I'll give it as 3000 mm, and now the line is fully constrained or fully defined here. So this was our first session showing the line command, how to apply relations, how to constrain the lines, and you have to remember that all the methods we have seen so as to give relation and constraint that will not only apply for line but for other geometrical entities also. So we will end this session here and continue with other session in next lecture. Thank you.